Hello, good evening all. So today we'll be doing the mock solutions for quiz 2. Am I audible?
Yes, ma'am.
Okay. I will present my screen. Is the screen visible to all of you?
Yes, ma'am.
Okay. Okay, I see one question in the chat. So maybe I think the confusion is because of the EMQ question we have. So no, it's not like connect. I mean, it's same as what you see for MSQ, right? Like MSQ, if you mark any wrong option, some marks will get deducted, right? But it never goes to a negative number. It's same as that. So whatever the EMQ questions are, if you mark any options to be wrong, then some marks will get deducted. Okay, I hope that is clear. So there is no such negative marking as in like it will not go from 0 to -1 or -2, no, nothing like that. It's more like the MSQ that you see. All right, then let's start now. Okay, so how many of you have done mock 2? Did you try?
Yes, ma'am. Yes.
Okay. All right, we'll go from the first question. So the first question says, the data from a firm is shown in the table M.1, right? Then in the table, what do you see? You see the first column as number of customers. And in second, you see profit in lakhs rupees, right? So number of customers in 1,000, like if we say 12, it means we're talking about 12,000 customers, 8,000 customers, and so on. And profit, if we talk about in lakh rupees, it means we're talking about like 14 lakh, 11 lakh, and so on. So given this data, can you find the sample covariance of this data, right? So how do you find the sample covariance?
X minus X bar, Y minus Y bar, Y minus Y.
I think my screen got stuck. Just hold on. Yeah. Right. So this is a table, and you have to do the you have to find the sample covariance, right? Find the sample covariance. Now to find the sample covariance, you see that So what is the first step that you will do? You will first find the mean, right?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. So let's find the mean. So let's say if I'm saying that X denotes the number of customers and Y denotes the profit. So what is the mean number of customers? So how do you find the mean? So to find the mean, you take the sum of everything and divide it by total number of observations. So in this case, it's 20 plus 30, 30, 38, 38, 13, it's 41. Sorry, 51, right? 51 divided by 5, correct?
Yes, ma'am.
And this will come out to be 10.2. So this is what we have done here. So we found X bar. So this is my X bar. Then we'll find the mean for the Y. So let's say if this number of customers is denoted by X and the profit is denoted by Y, then what is the mean for Y? It is just add everything and divide it by 5. So it is going to be 11, 9, 20, 30, 30, 40, 50, 55, right? 55 divided by 5, which is 11, right? Now the next step would be, so I'll make a separate table here, just for clarity. So you have X. So X is taking the value 12. Y is taking the value 14, right? X bar we got to be 10.2, Y bar we got to be 11. So now we do X minus X bar, right? And Y minus Y bar. We'll need this. So 12 minus 10.2. So just do everything. So you have 8, 10, 13. You have 11, 10, 9, 11. So what is 12 minus 10.2? It will be 1.8. 8 minus 10.2 is what? Minus 1.8 again. This is again minus 1.8. This is minus 0.2. This is minus 2.8. Correct? Similarly, you do for Y bar. So here everything, the table is already done. So let's use this. We had just remember X bar, we had gotten it to be 10.2. And Y bar, we had gotten it to be 12. Okay. So we find xi minus x bar, we find yi minus y bar. Then you need to do the product of these two, correct? Because you need to find the covariance. And covariance is given by xi minus x, yi minus y bar, sum over divided by n minus 1, right? So this is what we are doing. Now you just multiply and this is what you will get. So 5.40, 2.2, 0.40, right? So add everything. So when you add everything, what do you get? So 4, 5, 6, 6, 4, 10, 1, 5, 6, 7, 8, right? So 8 divided by 5. Oh, sorry, 4 minus 5 minus 1, right? Because sample covariance you want. So if you have to find the sample covariance, you need to divide it by n minus 1. So this gives you 2.0. Any doubt in this?
No, ma'am.
All right.
No, ma'am.
This was just using the formula. So you get the correct answer as 2. Now look at second question. So this is for second information for question number 2. So it says in a college, 100 students enter for the first year of engineering. So you have 100 people, 100 students who are in the first year, and a survey is done to know how many of them are willing to play chess. Okay. So this table gives you the distribution, gender-wise distribution, who plays chess or not. So we have made this contingency table, and the numbers shows like 15 male are willing to play the chess, 15 female are willing to play the chess, 40 male are not willing to play the chess, and 15 female are not willing to play the chess. So now using this table, can you select which among the following options are right? Right. So first option says approximately 50% of students who are willing to play chess are male. So that is correct, right? Because if you see, how many are willing to play the chess, first of all?
30.
This is 30. So 30 are willing to play the chess. Add this, and this is 30. And out of this 30, 50% are male. So that is correct, right? 15 by 30, this gives you 50%. So first option will be correct. Now the second one is approximately 27.27% of male are willing to play chess. So how will you find this? So how many male are there?
55.
55.
55. So out of 55, how many are willing to play the chess?
15.
15. So what does this number give you? 15 divided by 55?
Ma'am, the second option is right, 27.27.
0.27.
0.27. So second option is also right.
Yes, ma'am.
Correct. Now you have to check for the association between gender and their willingness to play the chess. So whenever you have to find the association, what do? You look for either row relative frequencies, or you look for either column relative frequencies. Then you see if all the row relative frequencies are similar, or if all the column relative frequencies are similar. If that happens, we say there is no association. And if they are different, we say there is association between the two categories, right? So in this case, let's say the column, the row relative frequencies, how will this table look? So this was our table, correct? Now we just do the total also, we add this extra row here. Now we divide each of these rows from the row total, right? 15 divided by 55. 40 divided by 55. 15 divided by 30. 15 divided by 30. And 30 divided by 85. 55 divided by 85. Right? So this will give you the row relative frequencies. Now, if we find that, we see that this turns out to be 27.27, roughly, and here it's roughly 73%. In the second row, you have 50-50, and in the third row, you have 35 and 64-65 approx. So you see all these values are like there is no similarity here, right? So whenever something like this happens, we say that there is no association. Sorry, we say there is association, right? Because the row relative frequencies are different for all these rows.
Then we can judge it by 55 and 30 as well, right? Or we cannot.
We'll judge it by
55 and 30, the values in the end of male and female rows. Total value. Yes, ma'am, the 55 and the 30. Can we judge it by those values?
these one you are telling.
Yes, ma'am.
These
Like,
one?
yes, ma'am. Like they are different. There is a considerable difference between them. So we can judge it by them, or we need to find these percentages.
Can you repeat? I think the voice I couldn't hear.
Ma'am, I shared that that there is we calculated the percentage as well as the total, and we can see that there is considerable difference between the total values of male and female. So can we judge by the value itself, or do we need to always find the percentage?
You are saying the values that we have is 55 and 30,
Yes, ma'am.
and from there we can say that they are different. Is it? No,
Yes,
no.
ma'am.
No. So what you need to look for the row relative frequencies or the column relative frequencies. So you need to look at these numbers.
Yes, ma'am.
This,
Yes, ma'am.
this. If they are very similar, then in that case, we conclude that they are not related or they are not associated. But you can see these all are very different, right? I mean, this 27, 72, or sorry, 27, 73, 50, 50, 35, 65 approx.
Yes, ma'am.
So this gives you this says that there is association between these two random variable, these two variables.
Ma'am, in female we have 50 percentage, right? Both are similar here in female column.
No, you need to this is it need not it's not like these two has to be similar. I mean, when you talk about the row relative frequencies, so we are talking about different rows. So you have row number 1, row number 2, row number 3. So if it was something like, let's say 27%, 73%, then you have, let's say 21%, 70, sorry, not 21. Let's say you have 25%, you have 75%. And let's say 24.5%, 74 or 75.5%. So you see these all threes are like the ratio between all these three. I mean, all for all these three rows, they're very similar, right?
Yeah.
I mean, the proportion in which a male is willing to play the chess or a female is or not willing to play the chess, they all are similar for male, female, and everything.
Yeah.
So if something like situation like this happens, then in that case we say there is no association. But this is not the case. In our case, what is happening when we are finding the row relative frequencies? All these are very different. These row relative frequencies are different.
Okay.
Yeah.
Yeah. So we have to check with each columns, right? As you said.
Yeah.
Yeah.
Correct.
Okay. Yeah.
Okay, I see one chart and
Ma'am, how much? Excuse me.
yes.
Ma'am, how much difference is sufficient to say data is associated?
I mean, quite close. Maybe maybe some in the interval of maybe you can see -3 +3, that would work. Yeah. I think my voice is are you able to hear my voice clearly?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Clear.
ma'am.
Okay, but for me your voice is quite low. So just let me check once. Oh no, okay. I'll leave it. Okay, so here you can see there is association. So the third option would be right, and the fourth option would be wrong. So option A, B, and C is the correct answer. Now let's move to question number 3. So it says all permutations of the word create with or without meaning are arranged in lexicographic order. So lexicographic order means that all the words will be in ascending order of alphabet. For example, if I'm saying create, so what we are saying is the words are arranged in such a way such that the alphabets should come in an ascending order, right? So you know the A comes first. So whenever you're making a series or whenever you're arranging these alphabets, so first you will start with the first alphabet, basically whatever is there in this word. So in this case it is A. So you'll start from A and then you will keep on increasing. So after A you will have C. Then you will have after C you will have E. You see it's 2 times. Then you will have R. Then you will have T. Something like this. Then when you make the next word, it will go like maybe TR, right? So it just this is the order in which you have to do. Okay. So what the question is asking you is what will be the 121st word? Like when you take this word create and all the alphabets that are there in create, if you try to arrange these in lexicographic order without repetition, and it's not necessary that all the words, all this arrangement should make sense. I mean, it can be of meaning, it cannot be of any meaning. That doesn't matter. It's just that all these alphabets you want to arrange in lexicographic order. Then if you do this, then what should be your 121st word, right? So you know that you will always start this with the alphabet A. So you have 1, 2, 3, 4, 5, 6. So you will always start with A and you will have 1, 2, 3, 4, 5 position left, right? So these 5 positions, how can you arrange it? You can arrange it in 5 factorial divided by 2 factorial ways, right? Why is this? Because E is coming twice. So you need to take care of that, right? So what is 5 factorial by 2 factorial?
60.
This. How much it is? Oh,
60.
60, right? Yeah. So when you start with 61st word,
divided by 2.
when you start with 61st word, it will start with E. It will start with C.
C. Yes,
right?
ma'am.
So again you have 1, 2, 3, 4, 5. So again you have 5.
Again we have
60 options, right? So till
Yes, ma'am.
120 we are done. Now we are asking 121st word. So 121st
E.
word, you know, it always start from E.
E.
Right? So you will start with E and then you will go in the order of the alphabet.
Lexico order.
Yeah,
Yes, ma'am.
right? So you will have A, you will have C,
C.
you will have E,
R.
you
T.
will have R, you will have T. Right? So this is your 121st word, which is option number D.
Ma'am, why option A is not correct? Because
Why
E after
option A is
E.
not correct? Because see, till 128th word, what you're saying is
And
the words will start from
and
C.
there
So
is also saying there is
no.
word is
So
also
you
saying that
now
lexicographic order.
121st word that you're going to start, that that will start from E, right? So that will always start from E. It is fixed. Now you
But
have
here
5
order
more
also
digits, 5
matter.
more places left. And since you have to arrange it in order, so and this is already fixed. So after E, you should always have A coming next. Right? If A was not there, if C was not there, then of course here E should have come. But here you see A, there is this A here, there is this C here. So the first word that should start from E should also always be E, A, C, E, E.
Ma'am, there you added another E, which
Another
is
E, yeah, RT, right? This. Okay, so this is going to be 121st word.
And the 180th word also, like, will have the after 181, maybe will have the same series, right? The next will be another E, right? In the lexical order.
You are saying when we want to fix this E,
Yeah, actually we calculate like
then
for the 60th we have first 60th
you
we
will
have
have
A.
5 factorial ways, right, to do
Yeah,
this?
yeah. And another next series will be like C will be coming first, and next 60 we have E will be coming first, and after next 60 also will be having E. The subsequently it will be moving right for the lexical order.
Yeah.
Yeah, okay.
Okay. All right. So question number 4. Question number 4 says 10 people participated in an online game tournament. So you have 10 people who participated, and out of these 10 people, out of which 8 participants has at most 3 stars out of 5 stars. So let's say all those people who are participating in the gaming tournament, what we are saying is that all these participants have some rating. So let's say there are 5 stars. So 1, 2, 3, 4, 5. What we are saying is out of these 10 people, 8 people have at most 3 rating. Okay, so 8 participants out of 10, 8 participants have at most 3 ratings out of 5 rating. Okay, now again, what we're saying is the game development company wants to take the opinion from these participants about the game environment. So in how many ways can they choose 5 participants without replacement? So you have to choose 5 participants without replacement such that at least 3 participants have at most 3 stars. Okay. So first of all, you have first of all, like, what is the company interested in? The company is interested in selecting the people. So company is interested in selecting 5 people. Okay. So 5 people without replacement such that at least 3 participants must have at most 3 stars. So the 5 participant, 1, 2, 3, 4, 5, the 5 participant that the company select, out of which at least 3 participant should have at most 3 stars. At most means maximum 3 stars. So it means either 3 participant can have at most 3 star, or 4 participant can have at most 3 star, or 5 participant can have at most 3 stars. All are these possible, right? So when okay, so how many ways can this be done? So how many ways the company can make this choice? So first of all, there were 8 participants. See, this 10 is very redundant here. You don't need this 10 because at the end you're talking about the people who have at most 3 stars. So we are going to mostly talk about these 8 participants that we have over here. So let's say 8 participants are there, and out of which we are selecting 5 participants. So when we are saying, so the first option can be, 3 people have at most 3 stars, right? So if that's the case, then you will select you will have to select A. So you have to choose 3 people, right? So 8 choose 3, and total you are selecting are 2 people, right? Oh, sorry, 5 people. So you still have to select 2 more people. Sorry, I said this is redundant, right? Oh, okay. That is not true. It is not redundant because you have to like select. I mean, you have to use those for like, okay. Let's see. There are 8 participants, and these 8 has at most 3 rating, and the remaining 2 has rating 4 and 5, right? This is what it says, correct?
Yes,
Is this
ma'am.
clear for this part?
Yes, ma'am.
Right? So when we are saying the 5, and you have to choose finally 5 people. So when you have to choose 5 people, so there are 3 options. There are 3 possibilities. So one is 3 people coming from the rating which has at least 3. 4 participants have rating at most 3, and 5 participants have rating at most 3, right? So now if we take the first case where 3 participants have at most 3 rating, then this can be done in 8 choose 3, because you will be selecting from this group of people, right? And see, you had to select 5 people, so you still need 2 more people. So if you still need 2 more people, those 2 people you will select from this group, correct? So this will be 2 choose 2, right? Now for if you want 4 participant that has at most 3 ratings, so it would be 8 choose 4 times 2 choose 1, right? And in this case, we'll have 8 choose 5. So you add all the cases, and you should get the number of ways in which you can choose 5 participants, such that at least 3 have at most 3 stars, right? So this is what we are doing here. We have 8 choose 3 times 2 choose 2. This is the first case. 8 choose 4 plus 2 choose into 2 choose 1 into plus 8 choose 5. That gives you 252. Is this clear?
Yes, ma'am.
Okay. Okay. Now you have question number 5. So it says, how many numbers can be formed between 999 to 10,000? So between 999 to 10,000, how many numbers can you form with digits 0 to 9 with repetition? Repetitions are allowed, such that having at least one of the digits has 5. So you see, between 999 to 10,000, you have all the numbers from 1,000, 1,001, 1,002, so on till 49999, right? So you want such digits, you want such numbers which has at least one of the digit as 5. So I would not consider 1,000 I would not consider, I'm not interested in 1001, not interested in 1002, I'm not interested in 9999. So what I want is, I want the numbers such that those numbers have at least one digit as 5 in that number. So I want 1005, yes. Do I want 1055? Yes. So you want such numbers which have at least one digit as 5 in that number. Okay, so this is what you're interested in. So how will you find that? How will you find that how many such numbers are possible? One way is like you count everything, but that will take a lot of time, right? So the other way is using the counting principle that you have learned. So see, since you want the 4-digit number, the first thing is that 0 should not be on the thousands place. So ones, tens, 100,000, right? So 0 cannot be here. This case is not possible. So you will, this for the 1000 place, you have only how many choices? 9 choices. And for these 100, 10th and ones place, you have 10 choices, right? So total how many 4-digit numbers can you make? So that would be 9 times 10 times 10 times 10, right? So these many numbers of these many 4-digit numbers you can make, and that is 9 times 10 times 10 times 10 minus you want all the 4-digit number that does not have 5 as a digit, right? So if you subtract all those numbers which doesn't have 5 as one of the digit, then that will give you the total number of ways in which you can total numbers such that these numbers have at least one digit as 5, right? That is true. So this was the total number of ways in which you can make the 4-digit number. Now, what about the total number of 4-digit number that does not have 5 as a digit? So if you have to make 4-digit number, and you know, you have to now, before you had 0 to 9 possibility, which is a total of 10 possibilities. And for the 1000 place, you had only 9 possibilities, right? And now, since you are saying remove 5 from this set, so now you don't have 5 in there. You have 0, 1, 2, 3, 4, 6, 7, 8, 9. So you have only 9 numbers, 9 digits now. And since you have only 9 digits now, I mean, you have reduced it to reduced to 9 from 10. So before, when you had 9 choices for the 1000 place, now you have only 8 choices for 1000 place, because we are discarding 5. So again, for the 100th place, initially you had 10 choices, but now you have only 9 choices, right? Again, similarly for 10th place, you have only 9 choices, and similarly for 1st place, you have only 9 choices. So how many ways can you make such numbers such that those numbers does not have 5? That would be 8 times 9 times 9 times 9, right? This is what we have done here. And now when I subtract these two, this should give me the total numbers which can be formed as digits from 0 to 9 with repetition, so that at least one of the digit is 5, and this gives you 3168. This is the answer. Is it clear?
Yes, ma'am.
Okay. All right. So next is find the number of words with or without meaning that can be formed from 5 distinct alphabets, taking 2 or more alphabets at a time. So you have 5 distinct alphabet. Let's say you have something. 1, 2, 3, 4, 5. All we are saying all are distinct. All distinct alphabets. It can be anything. They're all distinct, right? Now, you have to take at least 2. So out of these 5, you have to take at least 2. 2 at a time. 2 at least 2 at a time. So you can take either 2. You can either take 3. You can either take 2. You can either take 3. You can either take 4, or you can take all the 5. That is not an issue. So this there are 4 possibilities, and it also says that repetition of alphabets is not allowed. So it's like if you select two alphabets, you cannot repeat any alphabet. So that you should take care. Like repetition is not allowed. So how many ways can you choose this alphabet such that you can make words that has meaning, or and that is either meaning or without no meaning? That is not an issue. So if you have to make words which is of 2 letters, 2 alphabets, then how many ways can you select? It would be you have total of 5 distinct alphabet. Out of 5, you're choosing 2. So 5 choose 2, right? So 5 choose 2. And now those 2, I mean, let's say I choose, let's say it had, let's say I choose AE. Okay, these 2 I choose. So now you can again arrange this, right? You can make E times A. You can bring AE to first place, A to second place, right? That is also possible. This is basically 5 choose 2 times 2 factorial. Then the second case would be you make words that has 3 alphabets. So in that case, you will do 5 choose 3. 5 choose 3. And again, you can arrange it in 3 factorial ways, right? Similarly, 5 choose 4, 4 factorial. 5 choose 5, 1 factorial, right? This is what we have written. So 5 choose 2 times 2 factorial. 5 choose 3 times 3 factorial. 5 choose 4 times 4 factorial. Plus 5 choose 5 times 5 factorial, right? And this is, and you know the relation between permutation and combination. So this 5 choose 2 times 2 factorial is nothing but 5p2, right?
Ma'am, can you repeat?
You know the relation between permutation and combination, right?
Yes, ma'am.
So this is all these 5 choose 2 times 2 factorial is nothing but 5p2.
Yes, ma'am.
Right? So similarly, 5 choose 3 times 3 factorial is nothing but 5 choose 5p3. Similarly, all this can be written as 5p2 plus 5p3 plus 5p4 plus 5p5. I mean, this is not really necessary, but okay. So you solve this and you should get the answer. Right?
Hello, ma'am. I'm not getting. Can you please repeat?
So what we are saying is, see, in this question, we had what we are saying is, let's say I have 5 distinct alphabet. Okay. So I have 1, 2, 3, 4, 5. We are saying all are distinct. All are distinct.
Ma'am, in alphabets, like we have 6 alphabets, right? Like how we are choosing 5?
No, any 5 alphabets is given to you.
Okay.
Yeah. So you have only 5 alphabets given to you. Okay. Now you have to make words that has meaning or no meaning. It's not an issue. So you have to make words of 2 alphabets, 3 alphabets, 4 alphabets and 5 alphabets. So either you can use 2 alphabets, you can use 3 alphabets, you can use 4 alphabets, or you can use all the 5 alphabets. Okay, this is the question. Now, when you choose any 2 alphabets, then so you had 5. If you have to make words that uses 2 alphabets, so first of all, out of these 5, you will have to choose 2, right?
Yes, ma'am.
So that would be, so I'll just make 4 cases. So first is 2, second is 3, third is 4, and fourth is you can use all the 5 alphabets. So now if you have to make words for using 2 alphabets. So, and you have total of 5 alphabets. So from there you will choose 2 alphabet. So that is 5 choose 2. And now you can arrange these 2 alphabets at these places. So that can be done in 2 factorial ways, this arrangement. So number of words that you can make using any 2 alphabets with or without meaning is 5 choose 2 times 2 factorial, right? And this will give you what? 5 into 4, which is 20. So you can make 20 such words which are of which are of 2 alphabets, right? So you know 2 alphabets, you can make words like at, and, or anything. I mean, it does not have to even make sense. You can have AD, you can have AE, anything. You can have EA, anything. So whatever depends on what 5 alphabets is given to you, right? Now, if you have to make some word which uses 3 alphabets, then that can be done in 5 choose 3 times 3 factorial ways. Because you'll have to select 3 alphabet first, and then you arrange those 3 at the 3 places, which can be done in 3 factorial ways, right?
Yes, ma'am.
Similarly, now if you have 4, if you want to make word which is of which is of length 4, then in that case first you will choose 4 alphabets. So 5 choose 4, and then you arrange those 4 alphabets at 4 places, which can be done in 4 factorial ways. Right?
Now got it, ma'am.
Sorry, is it clear now?
Yes, ma'am.
Yes, ma'am, clear.
Okay, yeah, so this is all you have to do. Now, since you have to find the total number of ways, so you'll have to add all these 4 cases, right? So all the 4 cases that you have written, you have to.
It's better that we can go in by permutation way.
Yeah, I mean, fine, not a problem.
Yeah.
Yes, ma'am, I did it in the permutation way and it came right answer. And it gave right answer.
Right? Can you repeat?
I did it in a permutation way and it gave right answer. Like
Yeah,
we can
I mean,
directly
it will
multiply.
give the right answer, no?
Yes, ma'am.
Yeah. Okay, now let's move to question number 7. Okay, question number 7 says, in a bin, 45% of the balls are blue. So first let's make a bin. So here you have balls, okay? We are saying 45% are blue in color. So let's denote the blue with B. Denote blue by B, and we are saying 45% balls are blue in color, while 55% are red. So red, it's noted by R. and we are saying 55% or 55% balls are red in color. Now, among all the balls scattered there in the bin, a ball is randomly chosen from the bin. Okay. Now you randomly choose one ball out of the bin. So you choose one ball. What is the probability that the ball is blue and metallic if out of all the metallic balls, 60% of balls are red? So, okay, I think I missed the second sentence.
Yes,
Okay, the second sentence says among all the balls in the bin, 40% are metallic and remaining ones are of plastic. So let's denote all the metallic balls as M. And how many are there?
40%.
40%. And plastic is 60%. Okay. So
Yes,
let's denote it at P, and they are 60%. Now you randomly choose one ball. So what is the probability that the ball is blue and metallic if out of all the metallic balls, 60% are red? So there is one more information that is given to you. Out of all the metallic balls, 60% are red. So probability that the ball is metallic, given the ball is metallic, the probability that it is red in color is 0.60. This all information is also given to you. So what you have to find, what is it that you have to find out? You have to find out what is the probability that the ball is blue and metallic, right? So given that the ball was metallic and red in color, that probability is 0.60. So now you have to, like, what is the probability that the ball is blue in color given it is metallic?
0.40.
0.40, right? So this is what we have written here. So if till here, all this we are just denoting whatever information is given to us. These all are given to us, all this information. And from there, we concluded one more thing, that our probability of P given M is 0.40. This is what we have concluded. This information is more or less given to us. Now, what you have to find is what is the probability that the ball is blue and metallic. So when you say probability that ball is blue and metallic, it means you are interested in the joint distribution. That is probability B intersection M, right? And you know the relationship between the joint, conditional, and marginal. So this is given by probability B given M times probability of M, right? And what is probability of B given M? This is 0.40. And what is probability of M, which is, this is 0.40 again. So this gives you 0.16. So probability that the ball is both metallic and blue in color is 0.16. This is the answer.
Ma'am, during conditional probability, we will be there are three terms, right? One is the conditional one, and one is the intersection, and one is the probability one. So in three of them, always we will be given two, right? Two of them would be always provided.
Yeah, not necessary. Like, see, what we were interested in is finding the probability that the ball is blue and metallic, right? And we know that this can be found using probability B given M times probability of M. Probability of M is given to us. That was 40%, which is 0.40. But B given M was not given to us, right? This is what we have concluded from probability R given M. It is coming from there. We concluded this from there. So it will not always be given. You will have to like read all the information that is provided to you, and from there are a few things that you can conclude. So like from here, what was given to us is, out of all the metallic balls, probability that it is a red ball is 0.60. So out of all the metallic ball, what is the probability that the ball is blue? That is just going to be 0.40, 1 minus 0.60, right? So this is what we had concluded. So not all the information will always be given to explicitly in the question. There are few things that you will have to derive it from the information that is provided.
Yes, ma'am.
Yeah. Okay. Any confusion in this question?
Yes, ma'am. Also, there is a confusion, like when we have to use the Bayes theorem, and like this question. Now, as we have seen the solution, it seems quite easy. But when we haven't seen the solution, it was quite difficult to understand. Like we have to use the Bayes theorem or just a conditional probability. So, can you please give any shortcut or any trick to like understand what to use, either Bayes theorem or conditional probability?
Okay, I think next question is coming for Bayes theorem. So let's do first, and then we'll see why we didn't apply Bayes theorem here. Okay.
Yes,
Let's
ma'am.
do question number 8, and then we will come back again to this question. This is the information. It says students from 3 colleges have participated in a competition. So you have, let's say, college X, you have college Y, you have college Z. Now, 30% of the participants are from college X. So let's say this is my sample space. Where what we are saying is 30% are coming from college X. So let's say this constitute of 30%. This is some 30%. 20% are from college Y. This is 20%. And 50% of the participants are from college Z. So this is 50%. So this is what my sample space is. I mean, all the students who are participating in the competition, this is my sample, and all these are coming from different colleges. So it's like mutually mutually exclusive and exhaustive events, right? So there are some students coming from college X, some students are coming from college Y, and some from college Z. Now what we are saying is, if 50%, 40%, and 60% of the participants from college X, Y, and Z respectively are girls, then based on the given information, answers questions 8 and 9. So out of so from college X, so okay, how do I write this? Okay, let's make it here 20. Now I'll just remove these also. Let's say this is my girls, okay? These are for girls. And what we are saying is, from college X, 50% girls are participating. From college Y, 40% girls are participating. And from college Z, 60% girls are participating, right? Now, the question that is asked is, what is the probability that a randomly selected participant is a girl? So let's say from this group of girls, not from this group of girls, let's say you, from this whole bunch of people who are participating, you selected one, you took one person, you took one participant out of it, right? From this, choose one participant. So what is the probability that this participant is a girl? So I will denote girl with G. Okay. What is the probability that this randomly selected participant is a girl? So what are possibilities you can have? The one can be that this girl is from the girl is coming from college X. right? So this can be,
We use total probability.
sorry. So this is
union of
G.
girls.
This can come from either X, or this curl can come from Y, or this curl can come from Z. Okay, just hold on a minute. Okay, I think this is fine. So girl can come from Z, right? So what is the probability that the girl is coming from the college X? That is 50%. This is the probability that is given to you. So 0.50. What is the probability that the girl is coming from college Y? That is 40%. And sorry, this is not what I wanted to write. This is okay. This is not equal to this. I'm just okay. Wait, maybe I can write it like.
Ma'am, we can also do this like tree diagram. Mein.
What?
Total
Then we can
probability theorem में क्या?
Hello,
So
ma'am,
you
I am
understand
audible.
all the information, right? So this 50% is probability of a girl coming from X. This 40% is probability of girl coming from Y. 60% is probability of girl coming from Z. Okay, I'll just write like this. Now, when you have to find what is the probability that the participant is a girl, so this is just going to be, you have to use the law of total probability, right? So this is probability of girl coming from X times probability of X, right? Plus probability of girl coming from Y times probability of Y, plus probability of girl coming from Z times probability of Z, right? And all this information is already given to you in the question. So this is 0.50. Probability of X is 0.30, right? This is 0.30. This is 0.20. And this is 0.50, right? You just multiply everything, and this will give you the probability that the participant you selected is a girl, and it turns out to be 0.53. Is this okay?
Yes, ma'am.
Yes, ma'am.
Now the question is, if a girl is randomly
Ma'am, we
selected,
can apply Bayes theorem here also.
yeah, this is what we are going to do. Bayes theorem only we are going to apply.
Okay, ma'am. Okay.
So now we are saying, if a girl is randomly selected, what is the probability that she is from college X? So probability that the girl is from college X, given that it's a girl, right? So this is what? This is just probability X intersection G divided by probability of G. Probability of G we have already found here, so we don't worry about that. Now what is probability X intersection G? We can use the condition, the relationship between the conditional, joint and marginal, and we say that this is equal to probability of G given X times probability of X divided by probability of G. Now you already know what is probability of G given X. You already know what is probability of X. Then you can find, and you have already found what is probability of G. You use all this and you will find that if a girl is randomly selected, the probability that she is from college X is 0.283. Is this clear?
Yes, ma'am.
Hmm.
Yes, ma'am.
Okay. Now let me go back to the previous question.
Ma'am, can we do this question by probability tree diagram method or not?
Tree diagram.
Yes, ma'am.
Okay, if you use tree diagram, how will you proceed?
Ma'am, let total student is equals to 100.
Hmm.
Then 30 student from college X and 50 student from college Y.
So you are saying you do X, Y, Z.
Yes, ma'am.
X is you are
Ma'am,
going with the numbers. I mean, you're saying this is 30, this is 20, this is 50.
50. Then
Now
50% 50% is girl in college X. So it's 15.
So this is 50% of 30.
Yes, ma'am. So it's 15. 15.
15.
Yes, ma'am. 15 girls, 15 boys.
And what about
Ma'am, please show me the question.
yeah, girls, boys. You're saying this is 15, this is again 15. And this was
Ma'am, please show me the question.
40% of 20.
Yes, ma'am. So it's 8.
This is 8, right?
Yes, ma'am. 8
So,
girls in college
8
Y
girls,
from college Y and
12 boys. Then here 60% are girls.
30 girls from
30
college
girls,
from college Y.
20 boys.
Yes, ma'am. Now,
So if you have to find what is the probability of
ma'am, I think
that a randomly selected participant is a girl.
yes, ma'am. I think it's easy way.
Hmm?
Ma'am, I think it's easy way.
How will you find the probability that a selected participant is a girl?
From college X. So
No, not from college X. I'm talking about question number 8. Like any person you select randomly, what is the probability that it's a girl?
ma'am,
level
sum of all the girls divided by total students.
So it is 30, 45, 45, 53. 53 divided by 100,
100. Yes, ma'am.
right?
Yes, ma'am.
53 divided by 100. So this is right. Again, we got, yeah, this is what we got. Now, what is the probability that the girl is from college X?
So sum of all girls
15 divided by 53.
15 divided by 53.
15 divided by
53.
53,
Yes, ma'am.
right? Yeah, I think we'll get the answer. Yeah, we'll get the answer. Yeah, that's fine. Whatever you find easier.
Ma'am, I did this question like this way.
What?
Ma'am, we can do it by basic counting. That's I think.
Yeah, you can do.
Yeah. If someone doesn't understand this complex method of like total probability, then he or she can do it
Tree
just by
diagram.
counting.
Yeah. Now let's go back to our this question. So here the setup will be like, if this is my sample space, you have blue balls, you have red balls, and let's say this is metallic, and remaining we are saying non-metallic, right? What is asking, what is the probability that the ball is blue and metallic? Then you want to know this. How will you do it using Bayes' theorem? I mean, using simple probability, it's much easier than using Bayes' theorem here.
Yes, ma'am.
Yeah. Because what you want is, you want this shaded region, right? And using Bayes' theorem, it's little complicated. Maybe you can try from Venn diagram, maybe. But again, I think whatever you feel more comfortable with. I mean, there are many ways to solve any problem. Okay, what about this question? The question says, that the machine learning model, any machine learning model detects whether the given image is an image of a dog or not. So let's say you are given an image, and the model that you are creating, that will decide whether this image is a dog or not dog. So I will write dog as D and not dog as ND. Okay. Now it is found that given an image of a dog, the model predicts it to be a dog in 95% of the cases. Okay. So I mean, what we're saying is, let's say the image was of the dog and the model predicts it to be a dog. I mean, it is correct. I mean, it is a correct, whatever the model gave is correct. I mean, the image you gave for the dog and it predicted it to be a dog, that probability is 0.95. On the other hand, if the image is not actually a dog, it shows the image to be dog 30% of the time. So, I mean, the image was not given as dog, but it shows the image to be a dog in 30% of the cases, which is a false. I mean, so I will just write it as F. I mean, it gives the false conclusion. So this happens 30% of the time. Suppose you select an image randomly from a group of 100 images in which 40 are dogs. So let's say you have a total of 100 images. So you have a total of 100 images. Okay. Now from there, you take a sample of, let's say, some 40 dogs. You take a sample, no, not a sample, you select one image. And among this 100 dogs, you have 40 images as dogs. Okay, 40 dogs. Now, if you select one randomly, what happens is, if the machine learning model predicts it as dog, so whatever you have selected, if the model predicts it to be a dog, what is the probability that it is actually a dog? So I mean, it means the model is giving the correct answer. I mean, what model is predicting is right? So let's define some events here. So what we're saying is let's denote the event A as the event that the machine learning model predicts the image to be a dog. Okay. So A is the event that the model predicts the image to be a dog, and let denote the another event B as the image is actually a dog. Okay. So if I define these two events, what all information is given to us? The first is the model predicts it to be a dog in 95% of the cases. So probability, the model predicts the image to be a dog. So A given B, that is the image was actually a dog, this one is 95%. So this is 95%. If the image is not actually a dog, it shows the image to be dog 30% of the time. So probability of A given B complement, this is 30%. What does it say? It says, B says even that the image is actually a dog. So B complement will say image is not a dog, right? So when the image was not a dog, probability that the model actually shows it to the dog, shows it to be a dog is 30%, which is 0.30. Now, what is the probability of B? Probability of B as in the event that the image is actually a dog. So that is again 40%. So out of 100 images, 40 images we are saying is given to be of dog. So probability that of B, that is probability that the probability of the event that the image is actually a dog is 0.40, right? Now, if the machine learning model predicts it as a dog, what is the probability that it is actually a dog? So what do you have to find here? Probability that the model predicts it as a dog, which is probability of A, given that, sorry, not A given B, you have to find B given A, right? That is, if the machine learning model predicts it as a dog. So this we have defined as the event A, right? Let A denote the event that the machine learning model predicts the image to be a dog. So this is what is given to us, and you have to find the probability that it is actually a dog. So that is event B. So you have to find probability of B given A. Is this question clear? What you have to do? Yeah. So can you use the law of total probability here? So what is, you have to find, you understood that you have to find probability B given A. This is what you have to find. Now, how do you find probability B given A? So probability B given A is nothing but probability A given probability A intersection B divided by probability of A. And what is probability of A intersection B? This is probability of A given B times probability of B. I already know what is probability of A given B. I already know what is probability of B. So our numerator is done. Now, how will we find probability of A? So this will be probability of A given B times probability of B plus probability of A given B complement times probability of B complement, right? Can you, so all the information is already given to you. So you just have to substitute it and you will find the answer, right? Any doubt?
Ma'am, I didn't understand the labeling part, ma'am. Like, how did we label P of A by B?
How did we take the label?
Yes, can you please explain the first step, first two lines of the...
So what you should always check is, you should check what the question is asking. So my question was asking, so from here till here, all this is information that is given to us. Okay. But if you look at the question, it says, if the machine learning model predicts it as a dog, what is the probability that it is actually a dog? So you can define your event from here. So what is given in the, so this is the question that is asked. Now from here, you can define what is given to you and what you have to find out. So what was given to us as that the machine learning model predicts it as a dog. So I can define one event, let's say define event A, and I'm defining this event A as that ML model. So I'm writing machine learning as ML model predicts the image as a dog. And what you have to find? You have to find what is the probability that it is actually a dog. So you have to just look at this. So you can define another event B, which says the image is actually a dog. So once we define these two events, from here, you can write all the information that was given. So looking at what the question was asking, looking at what just the question was asking, the last sentence, I defined two events, event A and event B, right? Now, event A, we defined it. Now look at the question. It says it is found that given an image of a dog, the model predicts it to be a dog in 95% of the cases, right? So given the image of a dog means what? It is event B. So this is B, given B, the model predicts it to be a dog. So that was defined as event A, right? And this probability is 0.95. Now look at the second sentence. It says, on the other hand, if the image is not actually a dog. So if the image is actually a dog, you define it as B. Now, if you say the image is not actually a dog, it means you are given B complement. So given B complement, it's the model shows the image to be a dog. So the model predicts the image of the dog. This is what is you defined as event A. So A given B complement probability is 0.30, right? Now look at the third sentence. Suppose an image is randomly selected from a group of 100 images in which 40 are dogs. So it says, I mean, this information is given to you. I mean, like 100 images are there and you're saying we know 40 are dogs, right? So this probability, the image is actually a dog. This is probability of P, which is 0.40. So from here, so looking at the question, I wrote down the events, and now using these events A and B, I am writing down all the information that is given to us in the question. Is it clear now?
Yes, ma'am.
Okay. All right, let's move to the next question. The question says, Raju wants to collect rainwater so that he can use the water for future irrigation purposes. His land is of the area 1000 meters square. So let's say this is the land area. This is the land area. And this is 1000 meters square. Now, there is a large well of radius 10 meters constructed in his land. So in this land, let's say there's a well. So let's say this is a well. And what we're saying is this, the radius of this well is 10 meters. So So let's say this radius is 10 meters. Okay. This is 10 meters. Now, what is the what probability of water? So instead of writing I think proportion is better. So we will write proportion. What proportion of water? What proportion of water that fell into his land is collected by Raju using the well? So here you just have to like okay. How do you say that? Okay, so a well is 10 meter radius, right? So if you have to find the area that this well covers, what will it be? So this well is I mean, you will see something like this, right, on the floor, right? This is what you will see, the well, right, on this land. This is how it will look. Now this is 10 meters. So the area that this well covers is this is a circle, right? So this is pi r square. And what is this is what? Nothing but 100 times 3.14, right? So
Yes,
this will give you 314, right? Now we are saying out of this 1000 meters square area, the well is covering some 314 meters square, right? So what proportion of water will he collect that fell on the land? So this is just nothing but whatever area the well covers divided by the total number of the total area of the land, which is 314 divided by 1000.
Ma'am, but I don't think that's well because nothing about its depth is given.
Nothing about
Its depth is given.
depth is not given. That is why I'm saying this is not this.
This is, I think, there's some sort of printing mistake because this makes this question actually a bit irrelevant.
I think this is what the question looks like. But again, I find it a little ambiguous here. But
Ma'am, it was made a very simple question. Like if it was raining in a area of 100 meters square, then what is the probability that the rainwater would be falling in the well, the area of well? Just
yeah,
that, nothing. That's
nothing,
why
nothing much. Yeah. So area
that's
of
why
the
it's quite simple.
340 meters square, and the total area is 1000. So you divide it, it will give you the proportion, I mean, the amount of water that is falling on the land. That's all. I mean, it's a simple probability, but I think the wording has been a little better here. Yes. Okay. All right. Oh, now look at question number 12. You have to find probability that A intersection B intersection B union C, right? So how can you find this? The information that is given to you is probability of A, probability of B union C, probability of A union B union C. All these are given. And you have to find probability of A intersection B union C. So let's define these events. So my one event is A, one event is B union C, and other event is I mean, you have already, I mean, one is already defined here. So A union B union C, let's say. Now, what is A union B? So we can write this as maybe D. Okay. So probability of A intersection D. How can you get? I mean, what can you do to get this relation? So maybe you can look at probability of A union D. So this is given by probability of A plus probability of D minus probability of A intersection D, right? So from here, if I have to find probability of A intersection D, probability of A intersection D, I will write this as probability of A union D minus probability of A minus probability of D, right? So using this, now what you have to find is probability of A intersection B union C. So D is B union C. I'm just replacing it by that. So this is probability of A. It will be A union B union C minus probability of A minus probability of B union C. That's all. And all this is already given to you. This is 0.7, this is 0.2, this is 0.6. So this will give you the required probability. Is it clear?
Yes, ma'am.
Okay, you just substitute it. You will get the answer as 1 by 10. How many more questions are there? 3 more. Okay.
Ma'am,
All right. Here in question number 13, you have in the statistics paper of a qualified exam, there are 5 multiple choice questions. So you have 1, 2, 3, 4, let's say 5 MCQ questions, each of which has 4 possible answer options. So you must be very aware of these format. So 1, 2, 3, 4. Let's say each one has 4 options. Okay. 2, 3, 4. Find the probability that a student will not get all the answers correct. See, so for each of these questions, I mean, the correct answer is only one. So you have what you have to find is you have to find the probability that student will not get all the answers correct. I mean, even the first should be wrong, the second should be wrong, third should be wrong, fourth should be wrong, fifth should be wrong. So how many ways can students solve all the questions, right? I mean, how many ways can students solve the questions?
4 to the power 5.
4 to the power 5, right? Because this has 4 possibilities, it has 4 possibilities, right? And total number of questions are 5. So this is the total number of ways in which student can solve all the questions. So this is 1024. And out of these 1024, I mean, 1024 is the total number of ways in which a student can solve the question. I mean, a student can solve all the question. But out of these, all the out of all these ways, only there is one way, only there is one possibility that student will get all the answers right. Right? So if you reduce 1 from there, so the total number of ways was 1024. So you reduce 1, you will get 1023. So the probability would be just 1023 by 1024. Right? So you have option D as right. Is this okay?
Yes, ma'am.
Yes, ma'am.
Okay. Question number 14. In a family, 4 boys and 4 girls are there. So you have 4 boys and 4 girls. In how many ways the seating arrangement can be made in a row of 8 seats? So 1, 2, 3, 4, 5, 6, 7, 8. So in a row of 8 seats, such that no 2 boys and no 2 girls should sit together. So it shouldn't be like that there is a boy or girl. This should not happen. Okay, so you want something such that you want to make the arrangement in such a way such that no 2 boys and no 2 girls sit together. So how can you do this?
Ma'am, factorial of each seat, irrespective of genders.
Can you repeat?
Like 4 into 4. So the first place is for girl and the second place is for boy. And similarly, 3 into 3, the remaining one. Then 2 into 2, 1 into 1. And then we have to double this value so that if we repeat the process with with boy sitting in the girl's place and girl sitting in the boy place, then we will get the answer.
Yeah, right.
4 factorial into 5 factorial.
4 factorial into 5 factorial. No, right?
Ma'am, what I said was correct because I got answered that way.
Yeah, I mean, you just have to, whatever sitting arrangement you decide, again, you just double it. So let's say, since we want no 2 boys and no 2 girls to sit together, what we can do is we can place all the girls, let's say, at even numbers. Okay, so let's say I'm placing girls here, right? So this can be done in, and again, these can be swapped, right? I mean 4 choose 8 choose 4 and 4 factorial. This is more like 4 factorial, right?
Yes, ma'am.
So in 4 factorial ways, you can arrange girls in this fashion, right? And similarly, in the 4 factorial ways, you can arrange boys in this fashion, right? I mean, you can put all the boys on odd numbers, odd places, and you can put all the girls in the even places. And that would make sure that no 2 girls and no 2 boys are sitting together. But again, so this is one arrangement. Now another can be, you just swap the girls and boys place. So now in the next round, you make the girls sit on the even odd number of places and all the boys on the even number of places. So again, it is just going to be 4 factorial, 4 factorial. I can just do 2 times. This should give you the answer. Right?
Yes,
Is this
ma'am.
okay?
Yes, ma'am.
Ma'am,
Hmm.
just like this one, there, for example, I remember this one question. There is a word amendment. There is something, a word like this, amendment.
Amendment.
Yes, sir. Yes, ma'am. AMAD, like it's something like this.
Amendment. Amendment.
Yeah, the question which we did in amendment. Yeah.
Oh, you mean alteration?
Where did you do this question?
In the PYQ in the last.
Okay.
So basically, there was this condition which says that no 2A should be together. So what sir did basically is he created 5 spaces in between the consonants rest of the letters, so that those three A's can be in between any of the spaces. So that they should not, no two A's will be together in that case.
I'm not sure what question it is. So if you can put the question in the chart, maybe.
Okay, I will put it then. Just let me
Yeah.
find it.
Yeah, because I'm not sure what question it is, right?
There was a word, ma'am, and we solved it by using gap method. That's what he's asking, that why we didn't use gap method here, like 5C4 into 4 factorial, like that.
5 choose 4.
Means 5 gaps are there between 4 girls, and we have to choose 4 boys out of that. 5 gaps to be filled with 4 boys only. Then 5C4 into
How
4
is
factorial.
5? Why, like, when you say 5 gaps,
Yes, ma'am.
what do you mean by 5 gaps?
Means 4 girls, and every boy, every girl is between 2 boys. Means boy girl alternate method.
Oh, boy. Okay, okay. So one. Okay, you are saying is,
Ma'am, the one you have drawn in the below, it's the same, but we have to add one more girl in the front. That's what he's mentioning.
see, here it became easier because we had even number of seats. So when you have even number of seats, then I mean it's easier, no? I mean, there is, I mean, you only have to put either girls on the even place, or you can put boys on the even place. But if let's say there were 9 places, and 5 girls and 4 boys, let's say, then in that case, this is what it will look like, right? And now you're saying there are 5 gaps. So this is what you're saying, right? 5 gaps between all the boys. Right? This is what you're saying. This is the situation look like.
Yes, ma'am. Yes, ma'am.
Yes,
That's
ma'am.
why I'm solving like 5 factorial into 4 factorial.
5 factorial into 4 factorial.
Yes, ma'am.
5C4 into 4 factorial should be.
Can you repeat?
5C4 into 4 factorial.
Oh, okay.
It's permutation basically, right?
Yeah, permutation basically. It is 4.
Yes, yes.
5p4. So when you're doing 5 choose 4 times 4 factorial. So you're just choosing 4 places and you're putting the boys there and then arranging those 4 boys on those places.
Yes, ma'am.
Hmm? Yeah, this is right. No, I mean, this is what's the issue? Because you have to choose, first of all, you're choosing 4 places because you have 4 boys. So you by doing 5 choose 4, you're selecting, I mean, you're choosing all the places for boys. And
Yes,
now
ma'am. Yes, ma'am.
whatever places you have chosen, there you are arranging the boys in 4 factorial ways. So that will give you the answer. Here also what you would have done is, this is more like you select 4 places first, 4 choose 4, and then 4 factorial. So, but it will give you what? This is just 4 factorial only, right?
Ma'am, it will give 1.
This is 1, but 4 factorial.
And then you get the answer of.
Ma'am,
Yes.
ultimately it is getting down to 4 factorial. So
Yeah.
we can directly do that. With the permutation idea, it gets quite means we get quite complex idea about it, but we can do directly with factorial method. Like 4p4, so it's getting down to 4 factorial. So we can do it directly, right?
4C4 is 1, no?
4p4 p.
Okay, 4p4. But how is it coming as this? It is not coming as this, no?
Ma'am, 4p4 is choosing 4 things out of 4. That is 1, no?
Yeah,
Yes,
that's
ma'am.
what I'm
No.
saying. Mm. It's the same as this.
No, sorry. It's arranging 4 things
Ma'am,
permutation.
I mean 4p4 like uh, numerator will be 4 factorial and denominator will be 0 factorial, ma'am. So yeah, it's
Yeah,
actually will be 1.
arranging 4
So
things.
it will be 4 factorial only for the boys. So we can do it through permutation, I think so.
Yes, ma'am. I just confirmed it. It's 4p4 is equal to 4 factorial. 4p1 is equal to just 4. Yes. 4p0 is 1.
My pen is not working bit. Mm. Just give me a minute. Yeah, that's fine. Okay. Now this is clear, right? This question.
Yes, ma'am.
Okay.
Excuse me, ma'am.
Last one, yeah. Tell me.
Sorry to interrupt. I was actually searching for that question. Basically, in adamant, what we did is basically in this word, these how many ways these letters of this word can be arranged so that no two ways are together, and the spelling is ADAMANT.
I have posted the question. You can see in chat.
In how many ways can letters in the word adamant be arranged such that no two A's are adjacent to each other? Okay.
Yeah, and
So
the
one,
spelling
two.
is ADAMANT.
Yeah, I saw that. 1, 2. Mm. Okay, so how did you solve this? In how many ways can letters, should I write here?
480 ways.
What?
I think 480 ways.
400
Right.
240, ma'am. Answer is 240.
240.
So you have the word ADAMANT, right? You want to arrange this, so
And what
such that
actually
no.
I have doubt in is that sir created what sir did basically. I'm actually correlating this question with the question which we did earlier.
Right.
So basically, what sir did is he considered all the letters other than all the A's. So D, M, and T, and he placed them in such a manner such that no A's will be together. In whatever way we arrange them, A will never be together. So basically, each letter with the except A will be in between two A's. So like in alternate positions, basically.
Yeah, right.
Yeah, we can do that.
So it will
in
be
the
more
way
like
that I
D.
did it.
You have A. You can have N. Where do you put T? You'll have we need more one, right? C M N T.
Okay, ma'am. Sorry, ma'am. I got it, ma'am. Ma'am, I actually had the doubt. Ma'am, I actually was comparing both of them. So what I had doubt in basically is I actually thought if we are concerned here with the like if we arrange boys in let's say even position and girls in odd position. So we first created a case for that 4 factorial 4 factorial. Then we did the exact opposite. We arranged boys in even position,
Yeah,
girls
just
in odd.
huh.
So we did that. Basically, I was thinking that here we arranged all these letters except A in odd positions, let's say. Then why we didn't do that the same logic here? Like why didn't we apply the same logic? Why we didn't switch the position? And I realize that basically if we switch the position of A, no, yeah, ma'am. This is my actual doubt. Like why we didn't do that the same thing which we did in the previous question.
Okay, because N and T are together, and sometime they have to be different. They have to be at different places. So that's the issue. Because we have 3A and T are together at the end, you can see. So sometime we have to make it separate, like N in the beginning or T at the end. So it will get different. That's the issue. That is something different with our question.
Yeah.
That's why answer would be different.
No,
And
so what is the main key difference in this one and
So in the first, what we solved there, you had even number of places. I mean, you had equal boys and equal girls, right? So there it was easier to like fix the positions. So eight, right? 5, 6, 7, 8. So we know if we put all the boys on even places and all the girls on odd places, and then do the same thing and just swap again, I mean, that will give us the required answer. But here in this case, you have 1, 2, 3 A's, and you have D, M, N, T as I mean 4 of the other letters. So if you, let's say, you fix this, let's say, so this can be done. First of all, you'll have to select the places, because you have 7. You have out of 7, you need to select 4 places. Not 7 now. Okay, you have all
5
same
places for A?
5. So out of 5, you need to select 4 places.
Ma'am, 3.
You have to select 3, is it?
Ma'am, because
4
there are
places.
3 A's.
For 3A, we have 3 possible positions.
So 5C3. There are the beside from in the left side of A and also on the right side of T. There will be places where A will be like.
Ma'am, A's can be placed in 5 positions, but only 3 A's are there. That is why we need to fill in only 3 blanks.
Ma'am,
But
basically,
possible positions are 5.
Yeah, the possible positions are 5. Yeah, right. And you have to fill it in, I mean, you have to select 3 places for that, right?
Yes, ma'am.
So 5, choose 3. You select the places for 3, 3 A's. It can be anywhere. And now, let's remove this. Okay. So whatever 3 places you select, so now you have to arrange those A's, right? So let's say I put it here. It can be put here, or it can be put here. or any three places in such a way that they are not together, right? Or it
Yeah.
can be here, it can be here, it can be here. And then you don't have, I mean, some cases you will have um,
Ma'am, when you created that, ma'am, can you scroll up?
scroll up. Okay.
Ma'am, when you created that part, that particular part, that D space M space N, when you created that one, there
Which,
was you there this that was the like the exact pictorial view like what we got from sir also. Like
which
that
one?
uh,
You're saying when I wrote this one.
D space M space N.
Okay. A space and space T. This one.
Yeah, so beside D, the left hand side of D, there will be one space which we will consider. And on the right side of T, there will be another space that we are going to consider for A.
Why
So
will we consider it on the left hand side of T?
because out of these five spaces, A can be anywhere. So we have to choose three spaces out of these five for A. So there are total 5C3 ways of choosing these three positions out of these five positions for A.
Right.
Yeah, so sir did 5C3 and then he multiplied it by 4 factorial as these non-A's letter are also going to be arranged in 4 factorial ways, like 4p4.
Correct.
So he basically did that 5c3 into 4 factorial. So I was actually concerned that why we are not like in this case we are considering even and odd position for boys and girls. Why we are not considering even and odd position for A's and non-A's here? That's what I was concerned about.
Was this question in quiz 2, like in some previous time?
Yeah, it was discussed
Yeah,
in
it was.
yesterday.
Ma'am, such questions would be coming in exam also, because this seems quite as exam point of view. Because we
Of
won't
course.
have that much of time to think all about it.
You won't have this many number of questions on exams.
And ma'am, that I got the email and it's basically said that we are going to get the 0 marker questions, right?
You are going to get the EMQ questions.
The ones with carries 0 marks, and then if you get the main answer wrong, you will get marks if you do that 0 marker correct. Those are the
Right.
EMQs, right?
Yeah, EMQ one. Okay, let's move to the next question.
Ma'am, you didn't confirm this.
Confirm what?
Ma'am, that why we are not concerned about the position of A's and non-A's here, like we did in the boys and girls case. Like if they are
There, because it's even number of places.
yeah.
Yeah, so like there are only 8 places, right? So there, I mean, you fix the boys, then you have only 4 places left for girls, right? And if no two can sit together, then I mean, it can be done only in like even places, odd places.
Yeah.
Yeah. Here you have like 1, 2, 3, 4, 5, 6, 7 places, and 7 places. And here, I mean, you have only 3 A's and 4 other DM and T. So you have basically what you have 5 total of 5 we are saying, right? We are like considering all the A's as one, and you have D, M, and T. Now you want to arrange this. Okay, so if you like, you have fixed this, right? But it is possible that this is not the arrangement. I mean, you can have something like A, D, A, N, T, A. Did I write everything? M. This would also work, right?
Yeah.
Then you would, then this will also work. I mean, this is one also possibility.
So in
Right.
Sir's example, he didn't consider like this case. He only considered 5 spaces and then he 3
I
possible
don't know
spaces.
what how Sir did.
Five.
Okay. Maybe I can check that, and then I can tell you what, like, why 5 places have been considered there.
And because 3A's we can put anywhere, like before D and after T also.
Yeah, something like this.
Yes, ma'am. Ma'am, one of the A we can also put after M.
We can also put, yeah.
So that's why we consider 5 places and choose 3 of them to put the A.
Yeah. I mean, there is one, it is possible, yeah. So out of these 5 places, you have to select 3 and then you have to arrange it. Because see, if you look at this, I mean, A can be placed at any 2 places. I mean, there. So something like this. Then it is also possible that you can have something like this, which is maybe it starts from A, D, A, M, A. You can have something like this also, right? So for each of these non-A digits, there's a possibility that A can come either on the left or on the right. I think when you write all of this, right? I mean, all the cases, I mean, all these are possible.
Ma'am, I think we have to fix A's.
You have to fix what?
A.
Okay.
Then we got 7 situations, and
You,
for each 4 factorial ways.
can you repeat? Your voice was not clear.
Ma'am, if we fix A, then for each arrangement we can find 4 factorial ways, and and also A can be arranged in 7 such arrangement.
7 such arrangement.
What is the answer? Yes.
This is answer, right? 5 times 4, 12, 24. 24, 5, 120. What will this give? 5 choose 3. 5 into 4 is 20. Into 8, no? Wait.
4 factorial.
I think first to fix the consonant by 4 factorial. Then we get 5 places to fix A.
This is the answer you're saying, right?
Yes, ma'am.
Ma'am, please move to the next question.
Yeah, let's move to the next question and then we can discuss this. Okay, let's finish this.
Ma'am, very good evening. Can I have a little, ma'am, just one simple question, ma'am? Manu, this side.
No, please, let's finish this first. Do not, I mean, let's not break the
Ma'am,
flow
that
of the
is,
mock questions, okay?
ma'am, that is not related to this, ma'am, question. I just want to know, ma'am, just something little about the grading, ma'am.
Grading what?
Ma'am, for example, for the final, ma'am, this grading document for stats for data science one, and they have given a formula, ma'am. 0.1 graded assignment plus maximum of 0.6. And
That is not of concern for now. Let's focus here. It is not of a concern right now. That will be calculated only at the end of your final exam.
Ma'am, I just want to know that there is in the one part there's a lag of 10%. If we follow one part of this, then there's a loss of 10%. Ma'am, just want to clarify on that, ma'am. If you don't, ma'am, the formula is like that, ma'am. I can paste it on that, ma'am. For example,
No,
if
I
one
know the
doesn't.
formula.
Yeah, for example, maybe for some reason I'm not able to attend quiz 2, ma'am. So
Yeah,
that
so
will
you
be
will there will be some what do you say? You
Yes,
will
ma'am,
lose some marks for
10%.
that.
Yes, ma'am, 10%, what he was mentioning.
Yeah.
Most of them say
So
10%
this is
will
for
be.
like see, if the people who are doing 2 quizzes, they should have some I mean, they're rating all the exams, they should have some benefit, right?
okay, ma'am.
Yeah.
So if quiz 2 is ma'am missed, that means if the weightage has been reduced, or total marks weightage has been reduced from 100 to 90%. If quiz 2 is missed, ma'am.
Yeah, something like that. So that is all operational. So let's not worry about all this here. And let's do the last question. Okay, the question says you have a box A that contains 6 red and 8 black balls. You have a box B that contains 5 red and 4 black balls. Okay. Now a ball is chosen at random from box A and placed in box B. So you choose one ball from here and place it in box B. Now a ball is chosen at random from box B. Now you're choosing one ball from here. What is the conditional probability that a black ball was transferred from box A to box B, given that the ball chosen from box B is red? Okay. So again, you define the event. So let's define what is the question asked. The question asked what is the probability, conditional probability that a black ball was transferred. So a black ball was transferred from box A to box B, given that the chosen ball is red. So we have defined the event R as that the chosen ball is red, and we are defining another event B, which denotes that, let's stick to what they have done. So B denotes an event that a chosen ball is red. Okay, this is fine, right? And B denotes the event that the chosen ball is black. Yeah, the same one. Okay. Now what you have to find? You have to find okay. So then you also have to define events which says that when you were transferring the ball from box A to box B, define an event for that which says the ball transferred is red in color, or another event that the ball transferred is some other color, right? So let's define what has been defined here. And okay. So we are defining another event M such which says ball transferred is black in color. And similarly, we are defining an event N which says ball transferred is red in color, right? What do you have to find? You have to find the conditional probability that a black ball was transferred from box A to box B, which is probability of M, given that the ball chosen from box B is red. So the ball chosen from box B is red, is R, right? Okay, no, R is chosen ball is red. Okay, wait, think. All right, let's look at the question again. So here the question is asked, what is the conditional probability that a black ball was transferred? So this is, we can define this as one event. So one event is a black ball is transferred, and other event is the ball chosen from box B is red. So I can define N as ball chosen from B is red. Okay. So we have to find probability M given N, right? So this will be what? Again, you use the conditional probability. What is M given N? This would be probability of M intersection N divided by probability of N, right? What is when we say M intersection N, what do we mean? So M is that the ball transferred is black in color, and the ball chosen from box B is red. Okay, so when you transfer a black ball to box B, how many black balls will be there?
5.
5. And you have to, and okay, so this will be, so you can write this as probability that M intersection N, right? So this is ball transferred is black, and that probability would be what? Black was how many? 8. So 8 divided by total number of balls was 8, 6, 14. And the ball is red in color. is going to be 5 divided by, now you have transferred one ball here, so total number of balls is 10, right? So this will give you this, so this probability, this is giving me that the ball transferred was black in color and the ball chosen from box B is red in color. Is this okay? Now, what is probability of n? So when we say probability of n, it means what we want is that the ball chosen from box B is red, right? So again, you can have two cases. So the ball chosen is red means what? So this is one possibility, that the ball that was transferred was black in color and the ball chosen is red. And you can have the possibility that the ball that was transferred was red in color, which was 6 divided by 14, and you had selected a red ball, which is 6 by 10, right? This is what you should get. I think these all are written. Is this okay? Have we got this?
Yes, ma'am.
So yeah, so look at the question, define your event. So we have defined the first event as the black ball was transferred from box A to box B, and the second event as the ball chosen from box B is red. So that was our M and N, and we use the formula probability M intersection N divided by probability of N. Now M intersection N means what? That the ball transferred is from box A to box B is red in color, was black in color, and the red ball is chosen from box B. That is 8 by 14 and times 5 by 10. And the second possibility could have been that a red ball was transferred and you are selecting a red ball from box B. So that is why in the denominator we have this term also. Is this okay? All right, that was the last question. This is clear, right? Any doubt?
No, ma'am.
Okay.
Ma'am, when will we get the solution PDF in the portal?
The solution PDF is not uploaded.
No, ma'am. Can you please let them know that it is not uploaded and remind them?
Yeah, sure. We'll get it uploaded.
Ma'am,
What about probability of n?
What about probability of?
N.
Probability of n.
Denominator probability.
Denominator probability is what it is saying. Probability of n, what it is saying is that first of all, what is n? N is that the ball chosen from box B is red, right? Now, what the situation is that you are first transferring one ball from box A to box B, and then you are choosing one ball from box B, right? So when you are transferring one ball from box A to box B, either it can be red in color or it can be in black in color. Both cases possible. So that's why you have to take you have to consider both the cases, and that will give you probability of n. So the first is when you are transferring the black ball from A to B, then in that case probability of transferring a black ball is what? That would be selecting a black ball from A is 8 by 14. And now since you have transferred one ball, now you have 10 ball. So 10, and out of 10, you have 5 black ball and 5 red ball. So probability of selecting one red ball from box B is 5 by 10, right? Now, the second case is when you're transferring the red ball from box A to box B. So when that happens, so when you're transferring a red ball, so probability of selecting one red ball from box A is what? This is 6 by 14. And once you have transferred the red ball from box A to box B, now your red ball have become 6 and the total number of ball is 10. So that like selecting a red ball from box B is 6 divided by 10. So this is probability of n. Is this okay?
No.
Okay.
Ma'am, will the video be available soon? I was not there during the initial part.
It's streaming on YouTube, right?
It is streaming on YouTube, yeah.
Okay.
Ma'am, also I wanted to ask, will we get the weightage distribution?
Do you get what?
Weightage distribution of weeks, like we get in the end.
Not really. I mean, mostly the distribution would be like from week 5 to 8, 5, 6, 7, 8, you have majority of the topics and the majority of the questions, and week 1 to 4, you have maybe I would say 10%.
Okay, correlation and the other portions like correlation, covariance.
Yeah, from week 1 to 4, whatever the topic is, maybe some 10 to 15% it might come.
Okay, thank you, ma'am.
Yes, but majority is week 5 to 8.
Yes, ma'am. I need, ma'am, can you suggest some ways to practice Bayes theorem and other to like get into it and get clear our thoughts, I mean doubts?
I think Bayes theorem, if you have Sheldon Ross book, Bayes theorem, you'll find a lot of questions. I mean, there are a lot of textbooks, you can find questions. So
Okay, ma'am.
maybe I can just, I'm not sure if Walpole.
12th NCERT.
Also
from 12th NCERT.
I am not able to hear you. Can you repeat?
She says 12th NCERT.
No. Aman, can you tell me what she's saying?
She's saying 12th NCERT.
Even NCERT book has, yeah, right. So
Yeah.
Sheldon Ross book, I mean, even online when you search, you'll get a lot of questions from Bayes theorem.
Yes, ma'am. Bayes theorem and actually the week 8 is quite troublesome, so I need to practice it.
Week 8 is probability, yeah.
Yeah, thank you, ma'am.
Yeah, okay. Thank you.
Thank you, ma'am.
Yeah, thank you. Thank you all. All the best for your exam. All right then.
Thank you, ma'am.
Thank you.
The bonus in the